In this video, we're going to look at the first part of lesson 8.2 on trigonometric ratios. This is the first lesson that we're covering in Unit 8 on right triangles and trigonometry. This is a really cool chapter that's going to show you how the sides and angles in a right triangle are related. Our unit goal is to apply the trigonometric ratios of sine, cosine, and tangent to solve problems involving right triangles. In this particular lesson, 8.2, for day 1, we're going to focus on how do we write sine, cosine, and tangent videos. And then in day 2, which is going to be a separate video, we'll look at how to use right triangle trigonometry to find the missing side lengths of a right triangle. Before we define the 3 trigonometric ratios, we need to talk about the parts of a right triangle. Every right triangle has 3 parts. The parts are listed right here. So we have opposite, hypotenuse, and adjacent. Now, we're going to do the hypotenuse first. I just recommend doing that because that's the one that we're most familiar with. And as you know, the hypotenuse is going to be the longest side that's across from the right angle. So if you can find the right angle, which is that little box there, and go directly across from it, there you'll have the hypotenuse. So we abbreviate hypotenuse just with the first 3 letters, HYP. Then the second one that I want you to label is the opposite side. And the opposite side is going to be the leg that is across from the acute angle. So if my acute angle here is angle A, opposite, you kind of do the same thing we just did with the hypotenuse. You go directly across from that, and that's my opposite. And we'll abbreviate the opposite as OPP. And then the last thing we have to label is the only side that is left. That's the adjacent side. And the adjacent side is the leg that is touching the angle. So here, the adjacent side, if I look at angle A being my acute angle, the leg that's touching that is the adjacent leg, and we'll abbreviate that with the first 3 letters again, ADJ. So I'd recommend just doing that one last, and then it's the only side that's left over. Now these 3 parts can be used to write 3 different trigonometric ratios. So this is going to be an important vocab word here. So a trigonometric ratio is a ratio of 2 sides in a right triangle. And every right triangle, there are 3 different trigonometric ratios. The first is the sine. So if I go up to my picture here, I'm focusing in on angle A. And the sine of angle A is defined as the opposite leg. So opposite leg divided by the hypotenuse. This is often shortened with the abbreviations that we wrote above. So the sine of angle A is the opposite divided by the hypotenuse, or in short, O over H. And we'll talk more about that. There's an acronym to help us remember these definitions that I'm going to write after I've defined the remaining terms. So sine, opposite, divided by hypotenuse. Next, we have the cosine. And the cosine of an angle is defined as the ratio of the adjacent leg divided by the hypotenuse. This is often shortened with the abbreviation, so cosine A equals ADJ over HYP, or just A over H. And then finally, the last ratio that we have is the tangent ratio. And the tangent ratio is the ratio of the opposite leg divided by the adjacent leg. We can shorten that as opposite over adjacent, or just O over A. So here's a good way now for us to remember this, because it's kind of a lot to remember all of those definitions. So there's a cool acronym that has been developed to help you remember the names, and it's called SOHCAHTOA. So SOHCAHTOA helps us remember the definitions. S for sine. So sine is O over H. C for cosine, so cosine A over H. And tangent, O over A. So those are our 3 trigonometric ratios that we're going to be using all chapter: sine, cosine, and tangent. The easiest way to remember those is with the acronym SOHCAHTOA. In fact, I would recommend that when you're doing your work, that you just write that acronym at the top of your paper. SOHCAHTOA. And that's going to help us remember the ratios. Here we want to find the value of each trigonometric ratio, and we do not need to simplify the fractions. We're just going to leave the numbers as they are. So the first thing that you should do is look at the angle that it's talking about. It's always going to be talking about one of the acute angles. So in example 1, part A, we want angle A. So here's my angle, and now I'm going to label all the sides in relationship to angle A. So again, I like to start with the hypotenuse because that is the same in every single triangle, the one across from the 90. Then next, do the opposite, which is going to be directly across from the angle that's given. So here, opposite is 36. And then adjacent is the last one that's left. And now that we have those defined, we can go ahead and use them to write our 3 trig ratios. Let's start with sine. Remember that sine is the SO of SOHCAHTOA. So I'm going to go S equals O over H, SO. So we have the opposite in the numerator, which is 36, divided by the hypotenuse, which is 45. So that's the SO of SOHCAHTOA. Next, we have cosine, and cosine is the CA of SOHCAHTOA. So that's A over H. Well, adjacent side in our picture is 27, and the hypotenuse is 45. So the cosine of A is equal to 27 over 45. And now lastly here, we have the tangent ratio. And the tangent ratio is the TOA of SOHCAHTOA. So I have O over A. Opposite is 36, and adjacent is 27. So that is tangent of A, 36 over 27. Problem B, you'll notice, is the exact same triangle, but I have now switched the angle, and that's going to change things when we switch the angle, because now the angle that we're focusing on is angle C. Now you'll notice that the hypotenuse is still the same. The hypotenuse never changes. It's always across from the 90, but my opposite and adjacent are going to be different if I move to the acute angle C. Now the opposite, which is directly across from angle C, is 27, and the adjacent is the last side left, the 36. So if we go ahead now and we do our SOHCAHTOA ratios, I will start with the S, sine, that's the SO of SOHCAHTOA. So sine is opposite over hypotenuse, so that's going to be opposite 27, hypotenuse 45. Then we have cosine, which is the CA of SOHCAHTOA. We want adjacent over hypotenuse, so adjacent is now 36, and hypotenuse is 45. Notice that this is different from the answers that we had in part A. Because the opposite and adjacent switched places, our sine and cosine are different. They both have the same hypotenuse, 45, in the denominator, but the opposite and adjacent switched. So the sine of A is the same as the cosine of C, and the cosine of angle A is the same as the sine of angle C. And then finally, let's finish off with our tangent. So the tangent is the TOA of SOHCAHTOA. We want opposite in the numerator, which is 27, and adjacent, 36. So those are the trig ratios. I'd like you to try the next example, the try now, here on your own. Start by labeling the sides in relationship to angle X right here, and then see if you can write out the sine, cosine, and tangent ratios. Please pause your video now. Okay, here is your solution. It is angle X, so I started off by just labeling my sides in relationship to the angle, which you can see right here. So I did the hypotenuse, opposite the 90, 37. Opposite is across from X, so that's the 12, and adjacent is 35. And then we can use the SOHCAHTOA acronym to help us fill in the ratios. I would recommend that you just write this at the top of your paper so that you can look at it when you fill out your ratios. SOHCAHTOA. For our final example here for day 1, we are going to identify the angle that has the given trigonometric ratio. Because a trigonometric ratio can be written for either of the acute angles. So I have 2 acute angles here. There's angle A, and there's also angle C. So I'm going to start by labeling my hypotenuse, and that's going to be the same in all of the ratios. Hypotenuse never changes. So here, the hypotenuse is the 37. And then if I'm looking at angle A, for angle A, which I guess we'll start with here for this first one, the opposite angle A, if we go across the triangle, is 35, and the adjacent to angle A is 12. But if I switch to angle C, it changes. Opposite and adjacent are going to switch spots. So it might just be easiest if we just draw a quick second triangle. So I'm just copying that. And I'm going to fill in my 12, 35, and 37. And for this one, we'll focus in on angle C. This one I did the A. This one I'll do C. So the hypotenuse now doesn't change. The hypotenuse is still going to be the 37. It's across from the 90. But now the opposite of angle C is the 12, because that's across the triangle. And the adjacent is the 35. So now let's go ahead and figure out the problem here. So the sine ratio is 12 over 37. We need to use the acronym here to help us remember. So I'm going to write SOHCAHTOA at the top of my page. And sine is opposite over hypotenuse, O over H. So we have to figure out, well, which angle has the O as 12? So if I look at my picture, the opposite side being 12 is angle C, and the hypotenuse is 37, so that would be angle C. All right, let's try the tangent ratio. Remember, tangent is TOA of SOHCAHTOA, so tangent is O over A, and we have 35 over 12. So I need to figure out which of the triangles has a 12 as the adjacent and a 35 as the opposite. Well, notice the opposite being 35 is angle A, and the adjacent is 12, so that's going to be acute angle A. Next, let's try the cosine. Cosine is the CA of SOHCAHTOA, so I have A over H. If you look at the triangles that are drawn there, Adjacent side being 12 is going to be this one right here, adjacent 12, and hypotenuse 37, so that would be back to angle A. And the sine ratio is 35 over 37. Sine is O over H. So opposite 35 is going to be angle A again. Go ahead and try the try now here quick on your own. Please pause your video. Okay, for the last one, you should have gotten angle C. Opposite 12 is angle C, and adjacent 35, also angle C. That's it for day 1. We'll finish the rest of lesson 8.2 in the day 2 video. Thanks for watching. Bye.